Welcome back to my channel Kishore Sargi Pathshala. We are doing chapter Metals and Non-Metals 10 Cbse. So last time we have seen what is ionic compounds all about. So let's discuss ionic compounds in detail today. Now let's talk about the properties of ionic compounds. Right. For that what we need to do? We need to do two activities. Okay. Let's see these two activities. Let's take sodium chloride, potassium iodide and barium chloride, okay, from the laboratory. And what we need to do? We need to see their property. So let's see the physical state. The physical state of this salt is how they are hard and brittle, right? So they are hard and brittle. Secondly, if you take this salt in a spatula and if you heat it, so what you observe? You observe that the flame color changes for sodium chloride. That is, it will change to orange yellow. For potassium iodide, it will change to violet. And for barium chloride, it will change to green. And if you see that, are they melting in the spatula? No, they do not melt in the spatula. Right. Now let's talk about the solubility test. Okay. Let's take the given salt and let's try to dissolve the salt in water. Okay. Let's try to dissolve the salt in water. What will happen? Right. You'll see that these salts are soluble in water. Okay. So they are soluble in water. And if you take uh, petrol or kerosene in a beaker and if you try to dissolve this, you will see that they are insoluble in petrol or kerosene, right? Okay, now let's talk about are these salts they are conducting electricity or not, right? So what we are doing, we are taking the salt solution, we are putting water into it and we are preparing a salt solution, right? So let us test the conductivity of this salt solution. So we are having an electric cell here. Okay, so what we see here, battery has been connected, bulb is there to tell us whether the given salt solution conducts electricity or not. Right. So we see that when the circuit is complete, the bulb will glow. Okay, the bulb will glow. So what it indicates that their salt solution, they conduct electricity. Okay, and these are ionic in nature. Now to continue with, let's see the physical nature. Alright, so we see that ionic compounds are solid. So we have seen they are somewhat hard, okay, because of the strong forces of attraction between the positive and the negative ion. Okay, here you see the positive and the negative ion. These compounds are generally they are brittle and break into pieces when pressure is applied. Right. Now let's talk about the melting point and the boiling point of the ionic compounds. If you see the ionic compounds, they have high melting and boiling point. Right. Because there is a considerable amount of energy which is required to break the bonds between them, right? To break the strong interionic attraction. Okay, that strong interionic attraction, it requires lot of energy to break. So that's the reason you'll see that the melting point and the boiling point of these ionic compounds will be higher. Now, talking regarding the solubility, we see that ionic compounds are generally they are soluble in water. We have seen in the activity, and they are insoluble in the solvents such as kerosene and petrol. Right. So conductivity of electric current. So that also we have seen conduction of electricity. The conduction of electricity through a solution involves what? Movement of charged particle. Right. So the charged particle movement has to be there. Then only the electric conductive will be there. A solution of an ionic compound in water contains what? It contains ions, right, which move to the opposite electrodes when electricity is passed through the solution, right. Okay, then what happens, you'll see that ions are there, they are moving to the opposite electrode as such, and that's the reason you'll see that the bulb will glow and the electric current will flow through it. And ionic compounds, how these are, we have seen ionic compounds, they are solid, right, but ionic compound in the solid state, right, in the solid state they will not conduct electricity, only in their solution, in their salt solution, right, okay, they will conduct electricity, right. Why? Because ions are formed, okay, that we need to remember. But what happens in the solid state? In the solid state, what we see that there is no movement, right. Movement of ions in the solid state is not possible due to the rigid structure, okay, of the ionic compound, right. So you'll see that a rigid structure is there, and that's the reason in the solid the electric current will not be passed, okay. But the ionic compound conduct electricity in the molten state. Now what is the molten state? When you heat any of the solid, right, okay, when it reaches its melting point, that time it becomes a molten state, that is the liquid state. So this is possible in molten state since the electrostatic force of attraction between the oppositely charged ions are overcome by due to the heat, right. So what will happen, the charge between the two particles will be overcome by the heat, and that's the reason in the molten state ions moves freely and they conduct electricity. The movement will be there and the electricity will be conducted in this manner. Now we have seen the ionic compounds all throughout. Now let's talk about ores. Okay, so this is a very important topic. Let's see what it is all about. So mineral contains a very high percentage of a particular metals, right? So we know that many metals are useful in our day-to-day life. Like we have aluminium, we have copper, we have zinc, right, etc., which are used in our day-to-day life. Iron is there. Okay, now if you see, these all metals are not available in their pure form, right. They might be, they are available in the many of the mixture forms or the compounds forms as such. So minerals contains a very high percentage of particular metal, and the metal can be profitably extracted from it. So these minerals are called as ores. Okay, so now we are going to see how these important metals are extracted from these ores. The metal at the bottom of the activity series are the least reactive, and they are often found in the free state. What it's mean about? If you see, earlier also we have seen that we have gold, we have silver, right, where they are the bottom of the reactivity series, and often they are found in the free state. Okay, so here you see we have gold, silver, platinum, right, they are found in the free state. Okay, many of the times copper and silver are found in the compound states of their sulfides and oxide ore. Now the metals at the top of the activity series, right, at the top of the activity series, we know that they are very reactive, right, they are very reactive one, and you'll see that they will not be found in the free state. Like if you see, we have got potassium, sodium, calcium, magnesium, aluminum, they are reactive, and that's the reason what will happen, they will never be found in a free state as such. So we need to extract them from their particular uh, compounds as such. Now, the metals in the middle of the activity series, how they behave. In the middle of the activity series, like we have the zinc, iron, or lead, they are moderately reactive, right? Often they are found in the Earth's crust. How? In the form of oxides, sulfides, and carbonates. Okay, right. The ores of many of the metals are oxides. Why? Because oxygen is a very reactive element and it is very abundant on the earth. So what happens? The first element to react with any of the another element is what? Is my oxygen. Right. That's the reason on the basis of the reactivity we can group the metals into what? Into three categories we can group. How we can group it? The metals with a very low reactivity which will not react with others. Metals with a medium reactivity, right? And metals with a very high reactivity. These metals, as we have seen earlier, are at the top of the activity series, right? So what we are doing, based on the categorization of these metals, different techniques are used for obtaining metals falling in each category. So different methods are used to categorize, to extract them, right? By using these categories, right? So here you see a flow chart is there where you see that the techniques which we are going to use for the extraction, right? So you'll see that there are different ways like concentration of ores, and after that we are going to follow these steps. So student, I am sure you have understood today's topic. So we are going to see how the metals are extracted but dependent on the reactivity as such in the next topic. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.